So let us begin with the chapter 1 of the ICSE class 10th, that is force. When you apply force, there may be different types of effects on the basis of the object on which the force is applied. It means your object on which you are applying the force, it can be a rigid object, it can be a non-rigid object. Now what is rigid body or the rigid object? Rigid object is something which is hard. Even if you apply the force, it is difficult to change its shape, size or its dimensions or its structure. But a non-rigid body or a non-rigid object is something by applying the force on which we can change its size, shape, structure, we can change it. So now we'll study it in under two different sections. One is when you're applying the force on a rigid body, another when you're applying the force on a non-rigid body. If the force is applied on the rigid body, that is whose shape, size and structure will not change on the application of force. Now rigid body can be a pivoted body, it can be a non-pivoted body. Now what is pivoted and what is non-pivoted? Pivoted means it is fixed, non-pivoted means it is not fixed. I'll give you an example of non-pivoted first. Suppose a football is lying on the ground, it is not fixed, it can move. If you kick the football, it will move straight, that is it will follow which motion, linear or the translational motion. Another is your pivoted body. Suppose this is a pen, it is lying fixed here, it is lying fixed from this end. Now if you will apply the force on this pen, what will happen is it will move only in this way if you are applying the force from down, and if I am applying the force from the up, it will move this way, but this end will remain fixed. This end will remain fixed and it can only move this way. That is which motion it will be? It will be rotational motion. Next is when the force is applied on the non-rigid body, then what will happen? There will be the change in shape, size and structure. This question was asked in ICSE 2013 also. Next is your linear and translational motion. This we have already explained that when the force is applied on the rigid body and that rigid body which is non-pivoted. And rotational motion when the force is applied on the body and the body on which is pivoted. Then moreover, when the force is applied on the pivoted body, that is the body rotates about the axis passing through the point. This is the turning effect of the force and the motion of the body is called rotational motion. For example, force applied on the handle of the door makes the door rotate. We have seen that the handle of the door is fixed at one end, and when you apply the force on the other end, the handle moves. Now the important topic starts, the moment of force or the turning effect of force, or its third name is torque. This term in the 2020 ICSE they have asked the definition of this. Its definition is somewhat similar to rotational motion. What they're saying is when the force is applied on the pivoted body, the body rotates about the axis passing through the pivoted point. This is called the turning effect of force or torque or the moment of force. It was asked earlier in 2012 ICSE and it has been asked again this time in 2020. Now suppose this is your body and it is pivoted, that is fixed from this end A, and B end is free to move. Now let us suppose we apply the force on its pivoted end A. This end is fixed end and I am applying the force here only. Will the rod move? The answer is no. That is, to produce turning effect, one thing is now clear, that only force is not sufficient. That if we apply the force and the body will rotate or the body will move, rod will move, it is not possible. It means the torque or the moment of force or the turning effect, it not only depends upon force, there might be some another factor also on which the torque depends. So torque depends upon two factors beta, and this question was asked in ICSE 2015. First factor is the magnitude of force applied. Second is the perpendicular distance of the line of the action of force from the axis of rotation. That is, this is your pivoted end. Here where you are applying the force, this perpendicular distance also matters, that you are applying the force here, you are applying the force here, or you are applying the force here. So force, magnitude of force is important. Second, this perpendicular distance is important of the line of action of force from the axis of rotation.